Let's go to hash maps. So I don't know how many of you are familiar with hash maps already, but if not, this would be one of the best moments for you to learn hash map. So consider an array. Okay. So in order to check whether a particular element X is present in the array, you need to traverse through the array at least one time, right? The time complexity to do such a task is usually O of n for linear search. Now, can we do better? Yeah, we can. So that is where we actually use a hash map. Now, what is a hash map? So hash map actually uses a function called hash function in order to return the index of an integer if passed the integer. That the consideration would be like this. I'll show you a simple demonstration. So you don't want to look at this code, okay? I just want to show you. What if I use a hash function f of x such that I would always take x percentage 10, okay? And I need to pass the element 1, okay? And I need to pass the element 2, 3, 4, and 5. So the basic idea is when I pass 1 percentage 10 will give me what output? It will give me 1. And 2 percentage 10 will give me what output? It will give me 2. 3 percentage 10 will give me an output 3. And 4 percentage 10 will give me an output 4. So the idea is whenever I pass the element, I can get its particular index. So let's say my array is just this one, that is 1, 2, 3, 4, and 5. Then I can convert my hash function to x percentage 10 minus 1. So what if I pass the element 2? So when I pass the element 2, I have 2 percentage 10, which is equal to 2. Because the remainder when you divide 2 by 10 would be 2, right? And now 2 minus 1 is the index of 2 in this particular array, right? Because 2 is in the corresponding location of like the initial 0 and then 1, then 2, 3, and then 4. So 2 is against the index 1, right? So this would be index and this would be array. So 2 is against the index 1. So whenever I pass 2 in the function, I'll get 1 as the value. So what happens? Now I can check whether a particular element is in the list or not by having a complexity O of 1. That means just by knowing the value, I can check whether it is actually present in the list or not. Okay. If present, then what is its index? Okay. So that is the use of a hash map. And that is very important for us because whenever we want to reduce the access times, the data structure of our consideration would be hash map because it is really useful. Okay. So yeah, hash map is usually a combination of key and value, where key would be the particular kind of element that we need to search in the list or we need to find the index of, and v would be the particular index that we get. Now it is not limited to the case of key value considerations for the accessing element from an array. There could be different scenarios where we want to actually map particular things to a particular. For example, uh, your Aadhaar number against your name. Okay. So what if when I pass your particular Aadhaar number, I would get your name. So these are different things that I can do with the hash map. Okay, wait, what happened? Yeah. So which determines how it places the keys and values into memory. Hash maps are useful when you want to look up data, not by using an index as you do with vectors, but by using a key that can be of any type. Okay. Now see the example so that it will be more clear. I think this is hash maps. Yeah. So how to actually, so in order to get a hash map, you need to use this use command is similar to hash include in C or C++, and it's similar to import in Python or require in JavaScript, anything. So what we use this particular keyword is to get the required amount of library or the particular class or any kind of function that we need to use at this particular current program. Okay. So I require the hash map from the standard collections library. Okay. And that is why I use standard collections hash map. And then I have a main function where I create a new hash map similar to creating a new vector or a string. You just need to place hash map colon colon new. It means you create a new hash map. Now you need to place it as mute so that we need to insert values into the hash map. Now you see, I am going to insert using the insert function. So dot insert to string from blue to 10. So what happens is my key is blue and the value corresponding to blue is 10. Okay. Now scores dot insert string from yellow 50. That means my key is yellow and my value is 50. So whenever I try to access the element, like say I want to know what is the value. So print ln. I'll just show you that example only. So okay. So println, we'll just add one more element. Okay. So scores dot insert string from say red and let's give 100. Okay. Now I want to access the value corresponding to yellow. So how can I do it? I can do println the value corresponding to yellow is scores. Okay. Scores dot get yellow. Okay. Now the problem is usually when you use the get, okay, when you use the get, what happens is you would have a sum and none option that as you can see here. When you try to use the get, you will need to match it against a sum x and none x in order to actually define the kind of output that you need to get. So yeah, we will see what is the output in this kind of a scenario. Okay. Wait. Yeah, so you can see the error would be option integer cannot be formatted with a default formatter. So what we need to do in such a scenario is to use a match operation. Okay. So use a match operation. So how to do that? The basic idea would be let yellow is equal to match scores dot get yellow. So what I'm doing is I'm using the match scores dot get with the particular yellow value, and if sum of x existed, then I need to return my x. What if none? Okay, if it is a none, then I can return a was a negative 1. So I'm returning a negative 1 instead. Okay, now these both things are integers. Okay, we need to make sure that the data type that you return in both the cases are same. Now I can use this in order to print ln yellow value. Yellow's value is again pass yellow. Okay, now try execute because there. Yeah, wait, in line number 13 I have induced a semicolon. Okay, now it's executable. Yeah, so you can see the LO's value is 50 and that was the corresponding value against the hash map. Okay, so now we actually can access the corresponding value to the given key having the least time complexity, and that is the use case of a hash map. Okay, But whenever we use the get function, we need to actually use write a match in order to solve the issue. Okay. Now there is something called as overwriting. Okay, what is overwriting? Overwriting means if I am going to change, like let's say, so you know the value of LO is 50 right now, right? Now I'm going to just insert a new value, let's say 150. Okay. Now what do you think? Whenever I try to return the output using this println, what would I get? Would I get 50 or would I get 150? Okay, this is always the latest value that we get because the new value is inserted by replacing the previous value. So whenever now I try to return, I can see the LO's value is 150 because the previous value has been replaced by the new value in the hash map. Okay, so that is the idea about using hash maps. Now you can also print the entire hash map by using this println, but make sure you use the debug operator. Okay, so debug operator is very much important for us in order to print the entire hash map. So you can see this is how the hash map stores. It's similar to a JSON file where you can have a particular value against or key against its value, key against its value, key against, similar to JSON. Okay, and how can you actually pass through each and every character, sorry, each and every element, key and value pair? You can also use the for key value, which is a tuple representing key as the initial value and value as the next one. Okay, so key value in and scores. Now why are you using the and scores? Because you only want to take a reference. So you just need to print ln key and value. Now this actually enumerates the entire hash map into a set of key value pairs, which is actually a list of tuples. The first index in the tuple would be representing the key and the second one would be representing the value. I think the idea is clear. This is how we work with hash maps in general. Okay. So this is how we create a new hash map. We can insert value and we can access a particular value using the get function, and you need to match it so that you can have two different considerations, that is the sum and the none, because sometimes you are trying to access a color like say white, but white is actually not present in the hash map, right? So in this kind of a scenario, usually you would be prompted up by an error, right? So you can actually consider that scenario by using the none. Now you can have println to take a particular value, or even the entire hash map can be printed using the debug operator. And you can also print each and every value or the key value pairs using this methodology, that is an ampersand scores, which takes a reference to the particular hash map and then we will print it. Okay, I think the idea is clear. Go back to the slides. So that is what we have for in hash maps.